In this lesson, we will discuss how students will use decimals in addition, subtraction, multiplication, and division. In this lesson, we are going to go over some background information on operations with decimals. An operation is to add, subtract, multiply, or divide. Decimals are crucial for students to understand. In real-world situations, decimals exist in money, taxes, tips, distance traveled, weight of objects, and so on. Decimals exist everywhere, and it is an important skill for students to understand how to use them. Students in 4th grade fluently add and subtract whole numbers using the standard algorithm. The same method can be applied to adding and subtracting of decimals. Students are mindful of place values as they keep ones lined up with ones, tens lined up with tens, and so on. Students also add zeros in places so that all the numbers show the same number of places to the right of the decimal point. In 5th grade, students are limited to the thousandths place. Therefore, students will multiply tenths with tenths and tenths with hundredths, but they do not multiply hundredths with hundredths. 5th grade students may be given a problem such as 5 3/10 times 2 6/10. In this case, the student would be multiplying tenths with tenths. The student will also multiply tenths with hundredths, 3 6/10 times 4 75 hundredths. It is common for the student to multiply the numbers first without paying attention to the decimal and adding the decimal point at the end. In this problem, the student may solve the problem as 36 times 475, then put the decimal place 3 places from the right, due to there being 1 decimal place in the 3 6/10 and 2 decimal places in 4 75 hundredths. However, before students can make the generalization that the number of decimal places in the product is the sum of the number of decimal places in each fact, students must reason and explain why. If our students give us a correct answer, but are unable to explain how they got their answer or prove the answer makes sense, would we be satisfied? The answer is no. We want our students to reason with mathematics and justify their mathematical ideas. Van de Waal, a mathematician, states, even as students have already learned the standard algorithm, they need to know the conceptual rationale centered on the place value and powers of 10 for counting and shifting the decimal places. By focusing on rote applications of rules, students lose out on opportunities to understand the meaning and effect of operations and are more prone to misapply procedures. With the focus on strategies, strong place value understanding, and looking at problems different ways, we are encouraging our students to become thinkers and problem solvers. Students will use 2 methods to reason about multiplication of decimals. The first method is to think of multiplication as groups of or parts of. Students will color in groups of decimals on hundredths and thousandths grids. On this example, a student multiplied 3/10 by 4/10. 3/10 is illustrated in blue and 4/10 is illustrated in red. The overlapping area in purple is 12 hundredths. The answer to 3/10 times 4/10 is 12 hundredths because it shows 3/10 of 4/10. This is a visual method for students to see math operations happening. The second method is an extension of their understanding of multiplication of whole numbers with arrays and area models from 3rd and 4th grade. Students will use base 10 blocks to represent decimal numbers and build area models to show products. Students use the block to represent ones, the rod to represent tenths, and the cubes to represent hundredths. Students will have had multiple opportunities to explore and discuss their findings. They will use this to further their understanding of multiplying decimals and eventually lead them to the standard algorithm. Students may find it difficult to understand that multiplying a decimal by a decimal will yield a product smaller than the factors. However, we can remind them dividing by 10 is the same as multiplying by 1/10, and therefore can understand why 5 4/10 times 1/10 is 54 hundredths. From this, students can reason with fractions to prove that a tenth times a tenth is a hundredth, because 1/10 of 1/10 is 100th. Therefore, 6/10 times 8/10 is 48 hundredths. In 5th grade, your student will divide a whole number by a decimal, but not a decimal by a decimal until 6th grade. Students will learn that by moving the decimal place of the divisor to create a whole number, the decimal point in the dividend must also be moved in the same direction, the same number of times. Before students can make generalizations of moving decimal places in the divisor to the dividend, they must examine the patterns of dividing by tenths or hundredths. Fifth grade students should recognize that dividing by 1/10 is the same as multiplying by 10, and by doing so causes the quotient to be 10 times larger. Your student may come to this understanding through problems such as 7 divided by 1/10. It is the same thing as asking how many groups of 1/10 make 7 wholes. We then can think if 10 makes 1 whole, then 70 makes 7 wholes. So 7 divided by 1/10 is 70. The quotient is larger than the dividend. Students then can proceed to problems such as 7 divided by 2/10. How many groups of 2/10 will fit in 7 wholes? If 5 makes 1 whole, then 35 makes 7 wholes. Therefore, 7 divided by 2/10 is 35. Again, the quotient is larger than the dividend. The last concept we are going to cover is partitive and quotative division. They are more than just a tongue twister. Partitive is when the divisor represents the number of groups. 24 hundredths divided by 4, the 24 hundredths represents the total, and the 4 represents the number of groups. Students then see 24 hundredths is being partitioned into 4 groups. We then can see that there are 6 hundredths in each group. Quotative division is when the known divisor represents the number in each group. 2 divided by 25 hundredths, the 2 represents the total and the 25 hundredths represents the number in each group. We can take 2 wholes and section off pieces that are the size of 25 hundredths. As we shade in groups of 25 hundredths, we can see it takes 8 groups of 25 hundredths to equal 2 wholes. So, 2 divided by 25 hundredths is 8. The objective for this background lesson was to discuss how students will use decimals in addition, subtraction, multiplication, and division. We met this objective by discussing how decimals are used in addition and subtraction with the standard algorithm, and how students can discover the placing of decimals in multiplication and division. We also discussed how partitive and quotative division are used with decimals.